Hi, my name is Anne-Marie Mojor, and this is Lab 1, Charged Tapes. The purpose of this lab was to observe the interaction between charged particles using objects with excess charge and then calculating said excess charge. The lab objective was to create a computational model of the two charged tapes exerting a force and experiencing a gravitational force, as well as calculating the estimated net charge on each tape. The physics principles used in this lab were Coulomb's law and Newton's second law. Coulomb's law states that electric force is directly proportional to the charge of objects and inversely proportional to the distance between said objects. Like charges will repel and opposite charges will attract. I also used the electric field formula where E equals kq divided by r squared times r half, which is the unit vector, as well as the force gravity formula. Newton's second law was also used since there is no motion, so the force net would equal 0, meaning that force gravity and force electric are equal in magnitude but opposite in sign. The expectations for this lab were that if the U-tapes are created in the same manner, then when brought together they will repel. If U-tapes is positive and the plastic pen is negative, they will attract, whereas if the U-tape is negative and the plastic pen is negative, they will repel. If the U-tape is neutral and the plastic pen is negative, they will still attract due to an induced dipole being formed. To create a charged upper tape, I first cut a 20 centimeter piece of tape and laid it on my desk, creating a base tape. I then cut another 20 centimeter piece of tape, laid it on top of the base tape, and then ripped it off to create a charged U-tape. I observed that the U-tape was attracted to my hand, whereas the U-tapes were repelled by each other. The U-tape was attracted to a negatively charged pen, so it had a positive charge, and the U-tape was attracted to a neutral wall and book due to an induced dipole being formed. To quantitatively observe this effect, I placed one of the U-tapes on top of two books and called it tape B. I then brought the second U-tape under it and slowly brought it closer and closer together until an electric force was observed and tape B was repelled from tape A. I then measured the distance in which this repulsion occurred between them, which was 1.9 centimeters between the two tapes. To simplify the calculations shown on the next slide, I assumed that each tape had the same net charge since they were created the same way, and I treated each tape as a point charge in order to use the point charge formulas. I first calculated the force gravity on the U-tape by multiplying mass gravity and the y vector. I then set force electric equal to force gravity, and to solve for charge, I solved for Q. I found Q to be the square root of r squared, which was the distance squared, times force gravity divided by K, or 8.87 times 10 to the negative 9th coulombs. To find the number of electrons deficient, I divided the charge by the charge of one electron, or 1.6 times 10 to the negative 19th, and found 5.54 times 10 to the 10th electrons deficient. To find the ratio between the number of electrons deficient and the number of atoms, I first had to find the number of atoms. I did this by dividing the surface area of the tape divided by the area of an atom, and found 4 times 10 to the 17th atoms. Then for the ratio, I divided number of electrons deficient divided by the number of total atoms and found 1.385 times 10 to the negative 7th, or 1 electron per 7.2 times 10 to the 6th atoms. And here is a computational model. I have the constants listed, such as the K value represented by UF-Pez and the Q value, which is 1 electron charge. I have tape A and tape B represented by green and blue spheres, with tape B being the blue sphere. I have functions created for each of the major calculations, such as for force gravity, the charge calculations, the electric field calculations, and the electric force. I then represented this visually with the blue sphere representing tape B, the green sphere representing tape A, the red arrow representing the electric force, and the purple arrow representing the gravitational force. I found that the magnitude of charge of one piece of tape was 8.87 times 10 to the negative 9th coulombs. If the electrons had a positive charge and the protons had a negative charge, the same model would be observed, as the tapes would repel each other since they have the same charge. However, because it's electron deficient, the protons would have a negative charge, the overall charge of the tapes would be negative, so they would repel the negative pen. They would still interact with the neutral object, as they would still create an induced dipole. It was extremely important to handle the charged tapes as little as possible, because the electrons would transfer from the tape to other objects such as my hands. And this was important because if the electrons were transferred, this would reduce the net positive charge, which would reduce E, and the measured distance between the tapes would be lower and not be as accurate of a model.